Welcome to the next session of our discussion on design and analysis of algorithms. So we are going to discuss about greedy algorithms. Uh, in the last few sessions, you have looked into a specific example on greedy algorithms. Specifically, we talked of activity selection problem. So essentially what we want to discuss today in this session is what are the steps to design a greedy algorithm. So typically, if you recall, greedy algorithms are applied on optimization problem. So you want to cast your optimization problem as one in which we make a choice and we are left with one sub problem to solve. Okay, so the property of the problem should be such that it should be first of all an optimization problem where we make a choice. Okay, in that optimization problem we make a choice and then whatever we are left with is one single sub problem to solve. Okay, not many sub problems to solve but one single sub problem to solve. Okay, then so that's the first thing you need to look into. Then you prove that there is always an optimal solution to the original problem that makes the greedy choice. So what it is saying is, if you look at the optimal solution to your original problem, it is going to make the greedy choice. If I put the greedy choice, it's not going to hurt my optimal solution. So prove that there is always an optimal solution. There is some optimal solution to the original problem that makes the greedy choice. So if I put my greedy choice into to my optimal solution, there will be some optimal solution which makes that greedy choice. Okay, so that greedy choice is safe. Then the last one you should demonstrate is the optimal substructure property by showing that having made the greedy choice, what remains is a sub problem with the property, that is, we combine an optimized solution to the sub problem with the greedy choice we have made and we arrive at an optimal solution to the original problem. So what it is trying to say is that what you do is that first of all I should see that my optimization problem is such that if I make a choice, then I am left with one sub problem to solve. Then I need to prove that whatever greedy choice I am making, okay, there will be some optimal solution where this greedy choice will fit in. The third thing is saying that okay, you need to demonstrate that okay, whatever is the sub problem, once I get the optimal solution for that sub problem and I add this greedy choice to it, I get an optimal solution for the entire problem. So there is an optimal substructure. Okay, so these are the important sequences you need to see while designing a greedy algorithm. Specifically, if you look at a problem, typically we see an optimization problem. That when we try to attempt to solve an optimization problem, we see that whether we will apply a dynamic programming approach or greedy approach. Okay, so what will be the things you need to look into in order to decide that whether I should apply the greedy approach? So there are two important things which you need to look into. The first one is called greedy choice property. So that's your first ingredient. So what do? You want to see that in order to get a global optimal solution, you can do that by making some local optimal choices. Okay, so I can reach to my global optimal solution by making local optimal choices. Okay, so make the choices that looks best in the current problem. So I'm looking at the whole problem and I will make a choice which looks the best, that okay, this is going to contribute to my optimal solution, without considering that okay, once I have taken this much, okay, I do not see that how many other sub problems I have solved. Okay, so make the choice that looks best in the current problem without considering results from the sub-problem. So typically what happens in dynamic programming, you look at sub-problems of a particular size, okay, and you then make your choice that what is the best choice you can make out of solving all those sub-problems. So here we are saying no, we are not going to do that. We are making the choice that looks best in the current problem without considering results from the sub-problems. Okay, I'm not going to look into the solutions of the sub-problems. So the current choice may depend upon choices so far. So whenever I'm making this choice, it may depend upon whatever are my previous choices, but it doesn't depend upon any future choices. What are the choices I'm going to do in future? It doesn't depend upon that, right? So the current choice may depend upon choices so far, but it cannot depend upon any future choices or on the solutions to the sub-problems which are left. Okay, so it is not going to depend upon that. So it's perfectly fine to make a greedy choice, but you need to show that, okay, this greedy choice is going to work. Okay, fine. So that's the first thing you need to look into, that there is a greedy choice property. That means I can make a choice without looking into solutions of different sub-problems. Okay. The second ingredient is the optimal substructure. That's the important thing you need to look into. It's another thing which is there in dynamic programming, the optimal substructure. So a problem exhibits optimal substructure if an optimal solution to the problem contains within it optimal solution to the sub-problem. That's what is an optimal substructure means. That okay, if I look at my problem and I ask the question, okay, whether this problem is exhibiting a optimal substructure or not. So I will say, okay, I will look into the optimal solution to my original problem and ask the question whether it contains the optimal solution to its sub-problem or not. If it is, then it is following the optimal substructure. Okay, so that is also important. So because what it is saying is that, okay, I have my original problem, somehow I made a greedy choice and I showed that this greedy choice is going to stay in my optimal solution. Then only thing I need to be concerned about the remaining sub-problem which I have to solve. Okay, because my greedy choice says that, okay, it is going to be part of my optimal solution, then I will say, okay, now whether my problem is having optimal substructure, that means can I reach to the original problem's optimal solution by solving the sub-problem. Okay, the new sub-problem I got, can I solve just that sub-problem and whatever is the optimal solution to that sub-problem, add my greedy choice to it, am I going to get my original solution to the original problem. Okay, optimal solution to the original problem. Okay, so that's what is optimal substructure. So even though dynamic programming looks close to greedy, there are very specific differences. So for example, in dynamic programming, we make the choice after solving the smaller sub-problems. If you recall, in dynamic programming, what you will do is you will keep on looking into, you will start with your original problem and you will start decomposing it into smaller sub-problems. And you will try to solve those sub-problems recursively. You can apply memoization in order to implement it iteratively, but the basic idea is that you will look into the smaller sub-problems in order to solve the original problem, and you will say that, okay, I need to look into the solutions of these sub-problems, and that will tell me what is the best choice. Okay, so you do not make the choice first. You first solve the sub-problems recursively and then you make the choice. Okay, so in dynamic programming, we make the choice after solving the smaller sub-problems. Whereas in greedy, you do not do it like that. We make choices. Okay, we make choices first and then we solve the remaining sub-problem. Only thing I need to prove that my choice is going to be part of the optimal solution, some optimal solution. Okay. So that means dynamic programming proceeds bottom-up approach, right? So you start with the smallest sub-problems, you solve them, then that will give you what are the better choices, okay, best choices, and then you again solve, another layer of a little bit larger sub problems and so on. So you proceed from bottom to up. Whereas in greedy, it is a top-down approach. You are starting with the original sub-problem, you are making a greedy choice, reducing it to another sub-problem and saying, okay, I'm going to solve this sub-problem because it is following the optimal substructure. Okay, fine. So, these are the two important things you need to look into. So, both greedy and dynamic programming is based on optimal substructure property. That you have to be careful about. Okay. So I hope it is clear that what is it that you need to look into in order to apply a greedy algorithm. Remember, whenever you are using a greedy algorithm, you need to prove that it is going to work. Okay. And you now understand what is the difference between dynamic programming and greedy algorithms. Okay. So in the next class, we will look into another example of greedy algorithm called Huffman codes. Thank you.